Hey everyone, in this video I am going to show you my ThinkLink. It is called My Dream Classroom. So let's get started. This is a video of 3D printing and how it works.
They are learning through printing. Iowa State geology students are using one of the fastest areas of technology.
And Vanessa Payne shows us how they're getting a hands-on look at fossils thanks to 3D printing.
This is the GeoFab Lab at Iowa State University, and it's the first and only of its kind in the nation that's using 3D printing for research and teaching of geology. Now check this out. This is a tiny model they've made of Mars. Geology students are getting their hands on fossils that are thousands of years old without ever touching the actual fossil.
It's really transforming the way that we're understanding geology here at Iowa State.
ISU Assistant Geology Professor Franik Hashuk came up with the idea for this GeoFab lab when he noticed medical researchers were printing out their CT scans with 3D printers.
I said, holy cow, we need to be 3D printing out our rocks.
A digitizer uses lasers to scan anything from fossils to rocks. Then it sends a file to the 3D printer, which prints out plastic models. So what began as this fossil on the right is now a bright red model on the left. And for less than $1, the models are a lot more economical than the old wood hand-carved models they used to use in class.
This is a really cheap alternative, which allows us to give out numerous models to a lot of students.
Now students can see the pores in rocks or the topography of the Earth all in scale. And apparently students are more engaged than they have ever been before.
I can actually see what exactly teacher is talking to me, exactly what I could do, learn about it.
Even passing a model around, they take it, they turn it around, they look at it from different angles, and there's a lot more engagement, and you see people smiling.
This entire 3D printing system cost just $7,000, and it was paid through student computer fees and also faculty startup funds. Vanessa Payne, KTCI 8 News, Iowa's news leader.
Okay, so now going down to this little guy, it talks a little bit more about the 3D printing. And it says, not all 3D printers are the same. There are many ways to print, and all are different, mainly in the way layers are built to create the final object. Some use melting to softening to make the layers selective, to make the selective layers sintering, also known as SLS, and fusing deposition modeling, FDM, are the most common technologies using this way of 3D printing. Their size ranges from ones you can easily carry to ones that can make life-size objects. So now moving on to the multi-touch tables in the classroom. We'll watch this video.
The SynergyNet multi-touch project is being run from the School of Engineering and Computer Science at Durham University. The project team is researching the development and educational impact of multi-touch surfaces that can detect simultaneous contact with 2 or more fingers and be used by up to 5 learners at once. Educational psychologists are considering the impact these surfaces may have on classroom interaction, whilst the computer scientists are developing software that fully exploits this exciting technology.
The project came around from a new form of lab that we call the Techno Cafe, and that had an interactive whiteboard at the end. I soon became aware that certain sets of students that happened to be nearest the interactive whiteboard dominated that, and that was typical of what was happening in classrooms. So the essence of SynergyNet is fair and equal access, so everyone around that table will be able to collaborate and perform the tasks that is set by the teacher.
When you look at a multi-touch system, they're based on vision systems, and these vision systems give us information on what we call blobs. These are points of light that are given off by the fingers touching the surface. Those points are translated into just simple cursors that have an identification and a position on screen. We want to maintain what we call orientation independence, and that means that you can present content in whichever direction that you need to in order for it to face the person who's sat around the table. So we look at some of the computing challenges around the technology that we're dealing with, but we've also got education people and psychologists, and they've got a particular slant on what they see out of this project as well.
The type of pedagogy that I think is going to be important for this technology is really an attitude about kids engaging in learning themselves. They're coming into a world where there is more knowledge being created than we will ever be able to teach them in school, so they need to learn how to organise knowledge for themselves, how to continue learning throughout their lifetimes.
48 minutes. So why do you say that? Because it takes 15 minutes to walk to the park. Oh, right, so that...
The kids love it. The ones we saw in this morning, they were really engaged. But tying engagement to learning outcomes, that sort of research work takes a lot of time. One of the activities that we've done is this mysteries activities, where kids are given a number of clues to answer a question. They make the clues bigger if they think they're important. In a collaborative activity, you want everyone in the group to understand what the problem is and what ideas they're using to solve the problem.
That one's the main one. I'll sit them two together.
We're using what we're calling a social pedagogy. We're using the process of collaboration, and through individual students having to explain their work to other students, improve the depth of their understanding of the materials they're learning.
Here we've got the teacher console, and this is where we can set some of these challenges that we want the children to have a go at. So I'm asking them to solve 8 plus 6 over 2, and I can set what I expect to be the right answer. I can take a view of this table over there by just hitting watch, and now I can send the challenge to anybody on this table.
We know very well that as soon as a teacher involves themselves in group activity, just goes to observe for instance, the nature of that group activity starts to change. And being able to stand back and observe and know where things are going effectively, and to know which of the groups actually need your support, can better start to change the management approach. Teachers can direct their support to those that best need it.
The SynergyNet team is currently developing framework applications that are not just one-offs, but rather skeletons that allow teachers and other users to produce their own content.
We made a very conscious decision right from the start to have a licensing agreement that allowed companies to take and develop from our works, but also for it to be used by schools without cost.
Of course, there are lots of other people looking at multi-touch surfaces as well. There are rumours that people are developing multi-touch tablet PCs. There are already devices on the market that are offering multi-touch technology, but those devices are intended for single people to use. So the technology is becoming more prevalent in the marketplace already, and I can see that only ever increasing. I guess the model that we're looking at is interactive whiteboards that you'll find in schools at the moment. We do see the opportunity there for multi-touch to become as widespread and for it to not take too much technical challenge in order to operate them on a day-to-day basis.
We've developed sufficient framework now that allows us to do quite robust testing, and over a 3-year time frame I would hope we could gain quite an incredibly rich set of data that would be able to not only demonstrate that it has an overall impact on the learning experience, but precisely where that impact is, and also by getting teachers involved to be able to understand how the adoption of that technology can be best achieved if it is going to not only be present in classrooms, but it's actually going to be used effectively. Placing the technology in the hands of students could start to change the nature of education in that classroom.
Okay, here's a little bit more about the multi-touch tables. As you can see in the video, several people can be around the table at one time. Instead of one touch, the multi-touch tables are capable of up to 10 touch points at the same time, depending on the size of the table or screen. One can get a multi-touch monitor from 17 inches up to 84 inches. So, and then here is a video where they're doing testing on how durable these multi-touch tables actually are. So we're going to go ahead and watch that. Okay, so that's pretty cool. I don't know if all of the multi-touch tables are that durable or if it's just that select type of multi-touch table. Let's go ahead. Now we're gonna watch part of a video. It's the interactive floor, and I don't know if you can see that. So